Students, welcome once again to the Oval Academy of Education. In today's video, we are going to discuss here with ICSE Class 9 Physics. Book is Concise Physics by Selena Publication. Right. Chapter we are going to start here is motion. Chapter is second, that is motion in one dimension. So syllabus of the chapter is given here: scalar and vector quantities, distance, speed, velocity, acceleration, graphs of distance and speed, time, equations of uniformly accelerated motion with derivations. These equations are to be derived in this chapter. There is 1, 2, 3, 4. These are called equations of motion, right? For simple numerical problems. And now part A in your section is some terms related to the motion, right? So one thing special I am going to here discuss with you is we will also do exercise 2A of your back exercise 2A of this chapter side by side, right? So let us start. The first thing we are going to discuss in this chapter is what are scalar and vector quantities. So before proceeding in these quantities, these, as you know, these are physical quantities, right students? So these physical quantities, what are physical quantities? The quantities that can be measured. The quantities that can be measured are called physical quantities. This is the definition of physical quantities. So these physical quantities are classified into scalar, or second one is vectors. Scalars are also called scalar quantities and vectors are also called vector quantities, right? So let us discuss them in detail. So scalar quantities or scalars. So the physical quantities which are expressed only by their magnitude. These are called, these have only magnitude. The physical quantities having only magnitude are called scalar quantities. Magnitude means size, and size लगा लो, आकार लगा लो. These are called scalar quantities. They have no direction, right? For example is given here. If we say that the mass of a body is 5.0 kg, so it has, or let me say the mass of a body is 5.0. so this would make no sense. This kg has make it sensible, right? We have a body which is having 5.5 kg of mass, right? So the or we can say the mass of we are having a body which can be which is of 5 kg mass, right? So from this we can clearly understand that we need two parameters to express a scalar quantity or scalars, right? First is unit is like kg, meter, centimeter, and second is numerical value. This 5 is its numerical value, right? Constant or pure numbers like pi, phi, etc. has no units, will have no unit, right? So now what are the example of these scalar quantities? Example of these scalar quantities are mass, length, time, distance, density, volume, speed, temperature, potential of any kind, gravitational, magnetic or electric, work, energy, power, pressure, heat, quantity of heat, specific heat, latent heat, charge, electric power, resistance, density, mechanical advantage, frequency, etc., angle, etc., all the scalar quantities, right? So these have only magnitude. Please keep it in mind. This is their identification. The physical quantities having only magnitude are called scalar quantities. These are their examples and their properties. These are properties of scalar quantities. Scalar quantities can be added, subtracted, multiplied, divided by simple arithmetic methods. So scalar quantity is symbolically represented by its English letter. For example, for mass we write m, right? Time by t, distance by s, right? Length by l, right? So these are all scalar quantities. Now we will move on to the next page. Next page is of vector quantities. This is the definition of vector quantities. Vector quantities are the physical quantities having magnitude as well as the direction are called vector quantities or vectors. For example, if we say that displace a particle from a point by 5 meter, this is a point, we want to displace it 5 meter further, but we have no direction here. If we would have say it, we have a particle, please move it, displace it by 5 meter in the north direction or south direction. So we would have moved it in this direction north direction, this direction south direction, right? West or east direction. So the vector quantities requires not only magnitude but also direction. So to express a vector quantity we need numerical value of the quantity, its unit, and third is direction. So third direction is must here, right? So examples of vector quantities are displacement, velocity, acceleration, momentum, force, moment of force, torque, impulse, negative force is called torque, weight, temperature gradient, electric field, magnetic field, dipole moment, etc. are all vector quantities. So vector are represented by an arrow over their head. So if we want to represent force, so force will be represented, force is a vector quantity, it is represented by force. If we want to represent torque or opposite direction of force, we will put a negative sign here, right, before the F. So can vector properties of vector quantities are different from the scalars because vector quantities follow different algebra for their addition, subtraction or multiplication. A vector quantity is I have told you represented by English letter bearing an arrow over its head, right? Force is represented by this, velocity by this, or we can represent it acceleration by A or A. So these are vector quantities. So from here we will get answer of our question first, that is differentiate between scalar and vector quantities. Giving two examples I have told you here. This is definition of vector quantities on the previous definition of scalar quantity and their examples. So question 2 is state whether the following quantities is a scalar or vector. So pressure is a scalar quantity. Force I have told you is a vector, requires direction. Momentum also requires direction, so it is a vector quantity. Energy don't need direction, so it is a scalar quantity. Weight also need direction, so it is a vector quantity. Speed is a scalar quantity, it don't need direction. So students, so this was difference between scalar and vector quantities and answer to your question 1 and 2 of exercise 2a. Let us move to the next topic. So rest and motion. What is rest and motion? So as you have studied in the earlier classes, that every object in this universe is in motion. So you can see the daily life examples: flight of birds, car, buses moving, people walking, insects crawling, are more examples of motion. So our earth is always in motion, moving around the sun. So everything on this earth is also in a state of motion. This is the reason behind everything moving on this earth. The sun and star are also moving around the center of their galaxy in which they are found, and these galaxies are also moving. They are not at rest. So in absolute terms, nothing is at rest, always in motion. But we can define rest with respect to its surroundings of an object. Suppose a stone is lying by the side of a road. We will say that the stone is at rest, right? With respect to us, we are moving, the stone is at rest. So when we see a train leaving us from the station, we say that the train is in motion because it is continuously changing its position with respect to us. We are standing here, train is moving in that direction, so it is in motion. We are at rest. So though nobody is at rest due to motion of the earth, but with respect to surroundings, we can define rest and motion, right? So here arises your question number 3rd and 4th. When a body is said to be at rest? So here is the answer of this, here is the answer of this. A body is said to be at rest. This is rest, definition of rest. If it does not change its position with respect to its immediate surroundings. Keep it in mind. While a body is said to be in motion, this is a definition of motion if it changes its position with respect to its immediate surroundings, right? So for a moving body, if the distance traveled in a certain time interval is much large, if the distance traveled in a certain time interval is much large as compared to the size of the body can be assumed to be a point article. Please keep this point article in mind. It will come again and again in this chapter, right? So please keep it in your mind. So I have detailed 4 questions of the back exercise and the rest and motion, up to more rest and motion. So we will discuss the further chapter in the coming videos along with solutions from the back exercise. So it's time to say goodbye now. We will meet again in the next video with some more topics from this chapter. Till then, it's goodbye. Keep it on revising, and please make more and more shares, likes, and subscription to our channel. It will energy booster for us. Thank you. Goodbye now.